All right, in this video we are going to learn about a division process called synthetic division. We've talked about how to divide polynomials using long division or using box method to divide. They're kind of the same thing. Another method is synthetic. In some ways this is easier, although it's a little weird at first. But let's quickly review this first example, and we're going to divide using the box. If you remember, we're just using our box model. We're doing the opposite of multiplication. So x minus 3 is one of our factors that we're going to multiply together to give this original problem. Our answer is going to be what goes across the top of the box, that other factor. So we have to think backwards here. The first term goes in that first box. I think most of you are pretty good from there on how to finish this. But that's going to be an x squared. I would encourage you to pause the video if you need to practice it on your own. Then you multiply x squared times negative 3. The diagonal terms have to add together to give you negative 2x squared. So what plus negative 3 gives you negative 2? That is positive 1x squared. And then we just kind of repeat what times x gives you x squared. That's a positive x. And then we multiply. That gives us negative 3x. The diagonal terms in this case have to add together to give us negative 23. So that's negative 20x. You can see we've got no remainder because we end with 60, which is the last term. So our answer, when we divide that cubic by x minus 3, you get x squared plus x minus 20. It's important to know this other method, synthetic division. So synthetic division, we're going to get the same answer. It's a slightly different process. So inside, so kind of just go ahead and draw one horizontal line, and you kind of draw a little box right here. What goes in that box is the root of what we're dividing by in this problem. So we're dividing by x minus 3. X minus 3 has a root of positive 3. Where we get that if we take x minus 3 equal to 0, and you solve for x and you get positive 3. So that goes in our little box there. Next to that number, we're going to put the coefficients of this original problem. So our coefficients are 1, and then negative 2, negative 23, and positive 60. And in a very similar way, how we did this process, where we were adding and multiplying and just repeating that process, we're going to do the same thing here. So we're going to start with this first number 1, and we're going to add it to, well, there's nothing underneath the 1. We'll put a 0 there if we want. 1 plus 0 gives us 1. And so what this first 1 down here at the bottom represents, it represents the coefficient. Like we know our answer is going to start with a 1x squared. Well, that's what this 1 represents. It's going to be the coefficient for 1x squared. We'll get to that in just a second. And then we're going to multiply. So here's where this number in the box comes from. We're going to multiply 3 times the 1 there, and we get 3. And then we're going to add negative 2 plus 3 gives us 1. And again, if you look over here, that 1 represents the coefficient of 1 that goes in front of the x. And then we're going to multiply. 3 times 1 is 3. And then you're going to add. Multiply, add, multiply, add. we get negative 20. And again, you will see that negative 20, where does it match up with? It matches up with the negative 20 constant at the end of the final answer. 3 times negative 20 gives us negative 60. And then the 60s cancel out. That means we have no remainder. So remember, when you divide, we started with a cubic. And if you divide something with an exponent of 3 by something with an exponent of 1, you're just going to take your final answer down an exponent. So this 1 represents 1x squared. So x squared is just 1 degree less than the original problem. The next 1 represents coefficient of 1x, then minus 20. Clean it up a little bit. There's our answer. This seems a little overwhelming at first, but in the long run, this may be an easier method, and it's definitely a quicker method because we don't have to write out all of the x squareds. We don't necessarily have to draw the big box. We only have to write the coefficients, the variables, one time, and that's the end of the problem. So synthetic division, when you get to pre-cal, a lot of times you're going to be asked to divide and divide quickly. Synthetic is going to be the method you want to use. So let's go to example 2, and let's go ahead and divide this one just by, go and first divide it by box. I'm going to pause the video and let you practice this one first. You will notice this needs to be rearranged in standard form first. So combine like terms and write the biggest degree or biggest exponent first. All right, so that is what I got. I would encourage you to go ahead and pause the video and try to divide using box method. All right, here's what I got. May have thought you were making a mistake because we do get a giant remainder, which doesn't typically happen. There's our answer using box. Now try synthetic. So again, draw your box, draw a horizontal line at the bottom. The coefficients are 3, 13, 0, because there's a placeholder. Notice how they skipped. It went from a cubic, skipped the quadratic, and went to x to the first. So don't forget your placeholder. What goes in the box? Just look at what you're dividing by. Your divisor is x minus 3. The root of x minus 3 is positive 3. And remember, you're adding and multiplying. Adding and multiplying. That's all you're doing. So this first number always just drops down because you're adding it to nothing. So it's just a 3 underneath. And then you multiply this 3 times this 3, and you get 9. And then you add 13 and 9, and you get 22. And then you'll notice 3, 22. It's the same coefficients. 3 times 22 is 66. Add that to 0, you get 66. Looks like we're on the right track here. 3 times 66 is 198. 198 plus 14 is 212. 212 times 3 is 636. And I just realized I made a mistake with my box method because our remainder isn't just 636, but it's 636, whatever it takes to add to negative 636 to get to negative 21. With synthetic, this process is a little bit easier. You're just taking negative 21 and you're adding it to 636. Which I think is 615, which is what I should have gotten over here. And remember, these represent the coefficients. So how do we know what the 3 goes with? We'll look at your original problem. The original problem was an x to the 4th. Since we're dividing, we're just going to take it down a degree. So if the 3 goes with x to the 3rd, and then we just go right down the line. Plus 22x squared, plus 66x, plus 212, plus a remainder of 615 over x minus 3. I'm going to work out one more, but I encourage you to pause the video and try example 3. And I want you to just use synthetic this time. I will point out that notice on example 3, again, we have a placeholder. So you might put that in so you don't forget about it. So go ahead and pause the video and try to set this one up. I'm going to go step by step here and show you a few steps here in just a couple seconds. So again, this should be the setup. And then you're just going to add and multiply until you get to the end. There's the first couple of steps. The 5 drops down. 5 times 5 is 25. The negative 25 and the 25 cancel and give you 0. So there are the numbers I got across the top. And remember, this 5 is going to be the first coefficient, but it's going to go with x to the 3rd. It's going to go down one exponent. So it's 5x to the 3rd plus 0x squared. We don't really need to write that. Plus 0x plus a constant of 1 with a remainder of 10 left over. We always write, remember, the remainder over the original divisor. Pause the video and try your turn number 4. I'm going to put the answer up in about 8 seconds. There's the basic setup. And there's the numbers I got. So it should be 1x to the 3rd minus 2x to the 2nd plus 1x plus 3 with the remainder of negative 12.